Hey everybody. All right. I may not be there for one of my periods today for some unforeseen circumstances. So, what we're going to do is continue with stoichiometry. After this, you can spend some time finishing up that multi-mole conversions assignment and make sure that that gets submitted. But in order to get ready for tomorrow and the rest of the week and also next week, let's take a minute or take, I don't know, 7, 8 minutes. We're going to make a stoichiometry cheat sheet, kind of like a little, what do you call it? Kind of like a roadmap for how to do different stoichiometry conversions. All right, this will make stoichiometry conversions much more simple, much more straightforward as we move on with them. So get out a piece of paper or in your notes. Let's put it landscape. So let's make it sideways. Okay. And this is going to take up an entire sheet. So make sure it's, again, sideways. Make everything big, make it bold, make it colorful. I'm going to have a bunch of colors here. And on the left side of your sheet of paper, make sure we have like 3 ovals, boxes, squares, rectangles, whatever you want, looking just like this. We're going to have 2 in the middle. All right. And then on the right side, have 3 as well. And again, pause the video to do this. Don't say, oh, you went too fast, because you can pause the video. Also, make sure we have these arrows, because stoichiometry is all about converting between substances in chemical reactions. So to make that easier for us, because we're not always going to do moles to moles. All right, that's too straightforward. And of course, chemistry, we need to do things a little more detailed, a little more complex. So you can label this Stoich cheat sheet or Stoich conversion sheet or Stoich roadmap, whatever you want. And make sure you have these boxes. Make them big. We're going to put things in there, but also make sure there's enough space between for the arrows, because we're going to put things there as well. So again, stoichiometry is all about. Oops. Oh no. So stoichiometry is all about balanced equations and doing the conversions between the balanced equations. So on the top of your sheet, let's write down this fake equation. All right, I'm not using real elements. I'm just using a balanced equation. All right, so I have 1w plus 4x yields 2y plus 3z. So this roadmap is going to be about this reaction. Please don't think that all future conversions we do are going to be about this reaction. All right. Again, not everything you cook or bake is a s'more. So I'm just relating it to something that we are familiar with. So again, this is, you can say, is a balanced equation. All right. Each letter represents like a compound, and the coefficients up there are going to be used in this little roadmap. So what we've done so far in this stoichiometry unit is we have converted between moles of one thing and moles of something else by using this ratio. So in the middle of your roadmap, let's put on the middle left one here, this box here, moles of X. So I'm gonna use X as my first substance in this entire roadmap or cheat sheet. So the last couple days, you've been given, hey, if you have 23 moles of X, how many moles of something else can are related? So in order to get to moles of something else, we have to use this conversion factor right here. So if we were converting from moles of X to moles of Y, all we did was we would multiply by that ratio, 4 moles of X on the bottom because of the 4 there, and 2 moles of Y on the top because of the 2 there. So again, make sure you put this down in your roadmap. Use the same numbers too. Use the same colors. And again, not every single reaction we do in the future is going to be this, but this shows you how to do it, because we've been doing this so far for the last few days. So we've been doing this since we started Stoich, but stoichiometry is more than just moles of one thing to moles of something else. If you remember from, I don't know, February, we did all those conversions from grams, atoms/molecules, and liters. So that's what we're going to use for the rest of this cheat sheet. So on the left side, let's say that instead of me giving you moles of a substance, let's say I gave you something else like grams. So on the left side of your cheat sheet, make sure that we jot these down. All right. So in the top one, you can do grams of X. The left one, or sorry, the middle one, atoms or molecules of X. And the bottom one, liters of X at STP if it's a gas. And again, pause the video to put these in there. Take your time. But just like a roadmap, you can't just go, in this case, straight from like grams of X to moles of Y. It's impossible. Because in order to get to moles of Y, in this case, for this reaction, this Y, this green compound, you first need to get to moles of X and then convert to moles of Y. That's one of the hardest things for chemistry students with stoichiometry is you want to go straight from grams of something or liters or atoms of something to moles of something else. You can't do it. Okay? No matter how hard you try, you can't do it. This is why we need to write down the units and the substances because things will cancel out. So on the arrows, let's add what the conversion factors would be for these three conversions. Take a minute or two, jot these down. These should look familiar because we've done this before. We've converted from grams of something to moles by using the molar mass. We've converted from atoms or molecules of something by using the 6.02 number. And we've used the 22.4 liters to convert from liters to moles. Now, the reason this is going to be great for you is because I gave you what goes on the bottom and what goes on the top. Always. This is always going to happen. So if we're doing a problem where we start with grams of something, don't put the molar mass on top. Look, it says right here. So again, when you're making, mac and cheese at home from the box, you follow the directions, and it's very easy to do. If you don't follow the directions, then you make it wrong, and that's your fault. It's not mac and cheese. It's not Kraft's fault. So that's how you get to moles of X, and then you can get to moles of Y. So these are two steps. If you're trying to get from, again, liters of carbon dioxide to moles of a different substance in a reaction, you got to first go from liters to moles of carbon dioxide. See, X is the same substance. There's never, so as long as we have this roadmap, there's no reason to ever go the wrong way. Again, on a map, if you go the wrong way, that's your own fault. It's not the map's fault. So you got to follow the map, and you're golden. So this one's very straightforward. It even tells you everything. And again, don't always use 2/4. It depends on what you're going into. If I did this example with W and Z, I would have 1 mole of W on the bottom if I use W instead of X, and then 3 moles of Z on top. But I chose X and Y. All right. So now let's say you're not only going to moles of something, but you want to go to either grams, atoms, or liters of something else. Well, on the right side, here we go. You're doing the same thing. So take a minute, pause the video. On the right side, let's put these in these 3 boxes. And also the conversion factors needed to do that. So again, pause the video, take a minute, or a couple minutes, jot these down. Note that I'm using Y now. I'm not using X. X is gone. So once I convert from moles of X to moles of Y, X is gone. It's done. So if you're trying to get to grams of Y, don't use X's molar mass. It says molar mass of Y. Okay. So this is it. This is how we convert from grams of substance X all the way to liters of substance Y. We follow this roadmap. So on an example problem, which we'll do in the future very soon, let's say we have this balanced equation, and we're trying to say, hey, if I react 22 grams of this substance, how many liters of this substance should I make at STP conditions? Well, if you're given grams, right there, that's where you start. You have to follow the map to get to your final destination of liters of the other substance. Stop where you need to stop. Just like if you're on a train, don't pass your exit, okay? Or pass where you have to leave your train, okay? So stop where you need to stop. Keep going if you need to keep going. And this is a foolproof method, all right? And again, as long as you show units and your substances, things will cancel out. Note here, when you're trying to get to the grams, atoms, or liters, there's always 1 mole in the bottom because that's how many moles are in all of these numbers at the top. They're equal to each other. So copy this down. Make sure this is in your notes. We're going to use this in the future all the time when it comes to stoichiometry. So whenever we're doing examples, doing assignments, doing quizzes, assessments, whatever, make sure this is out. Cool. Thanks.